Yes, so I saw lots using the PCs, and I believe most of you at least have some basic knowledge of what the computer is. Yes, but these are the goals. So effective computer usage. Secondly, networking basics. So in this case, I'm going to give you some brief knowledge of some of the networking technologies that is being used. And some of these terminologies I'm going to explain in depth to you so that it becomes easier for you to know how computer networking actually works. And at your office, if you have some basic network issue, possibly you might try to solve it. If not, you can still, you know what to tell your IT people when they need be. And finally, adaptability to technological changes. So that's what I encourage students to adapt to the emerging technologies and also stay informed about the advancement in computing. Now, most of you are aware that AI is virtually everywhere. Most people use AI, especially the chat GPT, in doing so many things. There are lots that you can do with it. Now, in terms of the assessment for this particular course, attendance is going to be 10 marks. So today it looks like we're supposed to be 11. We have just 8 people in here. So meaning if they are unable to join, then they forfeit getting a 10 mark at the end of maybe the course itself. So I advise when we start lectures, you try as much as possible to be available for the course. Now, continuous assessments, this I'm sure might have been told, spoken about already by other lecturers, is going to be 30 marks. So in all, the continuous assessment will be attendance plus the 30 marks, making 40. And usually for my continuous assessments, I have in here individual presentations and lab practicals. So most of the quizzes would also fall within this. The end of exam, semester exams, you might have some MCQs or some practicals coming in. Now, this is not the final thing. This is just a tentative course assessment that I have. I can change it at any point in time, depending on how things go. Yes, Kwame, I think you have your hand up. Can you?
Yes, sir. Sir, most of our colleagues are at work as we speak. So it's not deliberately that they didn't attend the class. It's just that some are seek permission. The nature of their job didn't permitted them to join the class. So that's why you're seeing some of them not attending the class. I'm sure by next week they'll have their off days to join the class, sir.
That's okay. Don't worry much about it. But at least I need to have some sort of engagement with some of you. That is the main importance. Tell anyone who has a genuine concern of not being able to come to class, it's fine. That is how come we put up the recordings for you to see. So it's okay. So don't worry much. Attendance is just 10 marks. And personally, almost all my students get a 10 marks, and I normally use my quizzes as attendance. So if I put up a quiz for you to do, I expect you to do the quiz and use that one as a time that you came as more like an attendance for you. All right. I don't know if Kwame
Thank you,
has.
sir.
You're welcome. Right.
Thank you, sir.
All right. So as I said, this is tentative. I expect personally, I'm very confident most of you would get, okay, Kwame still has his hands up. Yes, Kwame?
No, sir, it's okay. I'm just putting it down. I've just answered the question, sir. You
All
just
right.
answered my question, sir. Um,
All right, so continuing, so this is just tentative. It can change depending on how things go. So we will move very fast because we just have 3 weeks to go. So now the objective for lecture 1, which is this particular lecture, is to help you appreciate how computers have evolved over the years and the presence, and also present some sort of, some of the uses of computers, which of course you already know. And I'll also help you, know the basic understanding of the computer hardware and other peripherals that exist in the area of computing and the mechanism of communication between some of these peripherals. And finally, categorize the types of software, and I also highlight the importance of the operating system software itself. If we were to be in class, this would have been the first question for you guys to solve. I would have asked you what a computer is. You would have taken a sheet of paper to answer all these. And unfortunately, we are not in class, so I will skip this and move straight to what a computer system is. But before I move on, I think it would be prudent for me to ask this question. Beatrice, can you tell us what you think a computer is?
Okay,
Just,
so
yeah.
a computer is an electronic device that accesses data, process data, and give out information.
Yeah, that is great. So generally, when we hear of a computer, it's the first key point that you have to have in mind is an electronic device. It first of all would need to be an electronic device. It should be able to accept data as an input. It should be able to process that data. That is the third point. It should be able to, after processing, it should be able to either store that particular data or bring it out as an output in the form of maybe a printout or so. So that is generally what a computer is. So usually when you hear of a computer system, it's a interconnection of hardware and software components that work together to perform a range of computing tasks. So that is a computer system. For the definition of a computer, that is exactly what Beatrice said. And in fact, her definition of what a computer is accurate and on point. And when you hear of a computer system, it's actually the interconnection of a hardware and a software components that work together to perform a range of computer tasks. We will delve into what the computer hardware is and what the computer software components are. So it is designed to accept, to process, to store, and to manage data. So these are very key when it comes to a computer system. It's supposed to accept, should be able to process, it should be able to store and also manage data, as well as also execute instructions to carry specific functions. Most of these, I'm sure most of you have an idea. So this particular lecture will be more like a recap of the little that you know or what you know in the area of computing. So the interaction and the coordination of these components, by components, I mean the software components and also the hardware components, makes it possible for the computer system to perform a wide range of tasks. So from a simple calculation to a complex data processing and also communication. So having a computer in our current state makes so many things very possible for us. We're able to do so many things at a go, things that would have taken us maybe a whole day to do. We can just use it within 5 minutes. We should be able to complete. Now that AI has even been in existence, has come to stay. An example of these AI like ChatGPT, for instance, if you wanted to generate some sort of report for you, you just feed it with some basic input or what you want it to do, then it will be able to provide you maybe a full-page document at a very faster rate, which so it helps in speeding up things, and that's made our life so easy. So a computer system vary in size and also complexity, from a personal computer and a laptop to servers and mainframe, which is used in large-scale enterprise environments. We would, of course, talk about the types of computer systems that exist. We'll talk about the other types of computers that are there. But generally, for the computer system, the size and its complexity, brings about the types that exist. We have ones that we normally use as our personal computers. And most times when you hear of a personal computer, it's a laptop that we have. And for organizations like GoFuels or wherever, we normally have the service that helps us, do certain complex computations compared to having what we can use our laptops for. we will delve into all of them and give explanation to some of most of these types that exist. Now, what is a computer system? Still under it, we're just continuing what we have in there. So a computer system typically consists of 3 primary units, often referred to as the basic functional units. So these units work together to perform the various computing tasks. And these are the 3 primary units that exist. We have in here, over here, we just have 2 stated in here. The central unit input-output devices, those are the 2 that has been stated in here. So as we move on to the next one, you'll see the 3rd one, which is memory. Now, which is memory over here. So now, when you hear of a computer system, these 3 things make up the computer system. We have the central processing units, the input-output devices, and also the memory units itself. So those are very key. Talking about the first one, which is a central processing unit, every PC or every computer that we have has a central processing unit, which we normally term as CPU. So you've been hearing people saying, my CPU is poor, my computer is slow. The CPU actually is considered as the brain of the computer. So without a CPU, the computer is not functioning. It's just like we, the human beings. If we don't have brains, we might not be able to coordinate with our central nervous system to maybe lift our hand or do other things. The brain is very key for our existence. So in the same way, the central processing units, or the CPU, is also very key when it comes to the computing system or the computer system. So the CPU is considered as the brain of the computer. The CPU is responsible for executing instructions and also performing calculations. So those are the 2 main things that the CPU does. And it can be categorized into these 2 units. We have the arithmetic logic unit, which is the ALU, and we have the control unit, which is the CU. So those are the key characteristics of the CPU. So if you hear of the CPU in a quiz or in an exam, whichever one it might be, you hear of the characteristics of the CPU or what makes up the CPU. These are the 2 things these are the 2 units that make up the CPU. We normally can say they are the characteristics of the CPU. So that is the arithmetic logic unit. Now, what's the ALU or the ALU is responsible for is the mathematical and logical operations. So by the CPU, it is the brain. It does instruction execution, and also it does perform calculation performance. It also does the calculations for us. So for performing calculations, all those center around this particular unit, which is the arithmetic logic unit. So that is the arithmetic, that is mathematics, logic. So that's the logical operations. So the computer usually understands things, 3 main operations, like the addition, subtraction, multiplication, and division, and 3 comparison operators, which is the less than, greater than, and equal to. And those are normally falls within it in performing these calculations. Now, in the area of executing instructions, this is where the control unit comes in. So it is responsible for the coordinating and managing the activity of the CPU. So for the hardware to talk to, the software and the hardware to talk, we need a CPU to help us to stand in for these devices to interact. And all the coordination, the way I'm moving my mouse and so on, it is the CPU that is helping me, coordinate with the software or the hardware, mouse hardware, to perform certain activity. So the control unit, which is the CU, which falls under the CPU, is responsible for coordinating and managing the activities of the CPU. So these are the 2 characteristics of the CPU. Now, when we talk of the input-output devices, most times we say I/O devices. So those are the input and the output devices. as the name says. So these are devices that helps us put in either data or information or whichever one or instruction into the computer. And the output are devices that also helps us, spew out or display certain information, certain things to us. So the function of the I/O devices or the input-output devices is to facilitate communication between the computer system and the external environment. So they usually allow the user to input data and also receive output. So these are the key examples that exist for the input devices and also the output devices. So for the input devices, the typical example is the keyboard. We have the mouse or mice. So that is a plural for mouse. We have the scanners, we have the cameras. These are all input devices. And for the output device, we have the monitor, printer, and also the speakers. These ones, I'm sure most of you have an idea of. So I'll move on to the next one, which is the third unit that makes up the computer system. So these, remember, there are three primary units that we normally talk about. So the third one is the memory units. So what it does is, that is the function of the memory units. It is used to store data and instruction, either temporarily or permanently, to facilitate quick access by the CPU during operations. So these are three characteristics of the memory. We have the RAM, we have the ROM, and we have the cache memory or the cache memory. Now, when you hear of the RAM, which is the random access memory, it's able to store information for a temporary period. It's unable to it's unable to store data for a long period of time. So, for instance, if I'm working in maybe Microsoft's Word and my PC shuts down right now, the random access memory is responsible for, whilst I'm working with the Microsoft Office, is the RAM that is actually helping save temporarily the program, the Microsoft Word program itself. Whatever I've typed, if the PC shuts off inadvertently, it means I'm going to lose all those records. However, for the read-only memory, it's able to store permanent information for essential system instructions. So that is the difference between the RAM and the ROM. Sorry. The RAM stores data temporarily, but the ROM is able to permanently store it for a very long time. We have the cache memory for high-speed data access. So, the RAM for temporary uses the cache for high-speed data. So, for instance, if you have maybe you boot the PC for the first time, you launch your Microsoft Word. It takes a very long time to launch. The moment you try to open it again, maybe you close it and open it again, most times it's very fast in opening. And this is mainly because set data has been cached in memory. So accessing that particular data makes it so easy and very fast. So these three units work in tandem to enable the functionality of computer system. So the CPU processes data and instruction, the unit stores, and the memory unit stores and retrieve information, and the input-output devices interact with the user and also the external devices. So that is the components that, these three, the CPU, the I/O devices, and also the memory, they work hand in hand to make it possible for the computer system to work, or for it to also perform its function. Now, this is typically some of the components that make up the computer system. So we have the keyboard, this is how the processor looks like. This is an example of the processor. There are some few things that it goes on in there that helps things to work. So we enter information, it goes into the computer, the processor processes it, either stores it in memory in a computer hard disk, or it comes out as a printout. So this is a monitor, this is a processor and keyboard. These are external devices that we can use to store data. So this is what it does. So the keyboard sends information to the computer. Some coordination and processing or arithmetic information, calculation is done over here if the need be. And once we are okay with it, then it's sent to the output device. And in that case, if it sends to an output device like the printer, then we have records of what we were doing. If we don't want to print it out, we can in turn save it onto a disk. That is also one thing that we can do. And finally, if we don't want it, we can just display it on a screen for us to see what's the final outcome of what we were doing. So that is the how the computer system really works. So devices that comprise of the computer systems are what has been outlined over here. We have these devices. So generally, when we talk of a personal PC or personal computer, we normally have these devices in there. These are external stuff that we can also add to our computer and also use. All right, so that is it. So that is how generally you have an idea of the computer. So before we can even appreciate all how a computer does most of its computations and also coordination, it just didn't start here. It evolved with time. Just how kids are, a man and a woman meets and the fertilization occurs and an embryo is formed and a fetus comes in until eventually a baby comes in. So there is some sort of evolution that goes on before a human is possibly born and he grows. So in the same way, computer just did not come in. So we have what we call the evolution of computer. Where did computer really come from? It took a while before we were able to get to the current state of the type of computers that we see. So the modern computers are vastly different in appearance and performance as compared to those of the earlier days. To fully understand the impacts of the computers on today's world and the promises that it holds for the future, it is important to understand the evolution of computers. We need to know how computers have evolved over time to what we see now. So in terms of that, the evolution of the computer spans several generations. It's characterized by significant advancements in technology, architecture, and also capabilities. So we're going to go through the overview of the major changes in the evolution of the computers that we have. All right. So now let's talk about the first generation computers. And that's actually started in 1940, 1940s to 1950s. Generally, that is what we normally say is where the evolution of computers started. Other people will also say it started in the times of Babylonians, where they were not using electronic devices, but they were actually using mechanical devices like the abacus and so on. But if we stick to our current generation, we would say the first generation of a computer evolved or emanated from the 1940s to 1950s. Now, these PowerPoint slides that you see here, I have, when I roll all of you on board, you would have access to the e-learning where the lecture material would be there. I'll also put up the PowerPoint for you to also see. So you wouldn't miss a thing. So the first generation of computing technology refers to the initial phase of the electronic computers. So we are talking about electronic computers in here, not the mechanical ones. If it's a mechanical, then Charles Babbage would have been the first person who, part of the people who actually brought to light something they called the computer in that sense. But in the initial phase of the electronic devices, for the generation of a computer, the evolution actually started from here. So which emerged in the late 1930s, somewhere 1939s, thereabouts, and lasted through the 1950s. So these computers were characterized by the use of vacuum tubes and the primary electronic components for processing and also memory. The vacuum tubes, usually, you see those that have seen those old type of, black and white TV. That is how you see how the vacuum tubes look like. Virtually, that was how it was characterized to be. So the first generation computers laid the ground of the subsequent development in computing. And these were the characteristics of the first generation computers, which is within this particular year, this decade. The vacuum tubes used an electronic component. There were binary systems and also machine learning programming and batch processing nodes and also limited memory and also processing speed. Of course, when they brought up all these, there has some limitations with the memory. Some years back, if I'm sure most of you will even attest to what I say, even to have a pen drive of, let's say, 2 megabytes, if you have a pen drive of 2 or 4 megabytes, then it means you're a rich person. Now, 2 megabytes doesn't do anything to us, We are thinking about now the pen drives are even in 120 gigabytes and so on. So yes, at that time, memory was an issue and the processing speed was an issue. We need a processor. This processing speed, that is where the CPU also comes in. So during that time, the notable PCs that exist, in quotes, were the ones that had been outlined here as electronic numeric integrator and also calculator, the ENIAC, the universal automatic computer, the electronic discrete variable automatic computer. And by this is how they looked like. So these were the things that we actually thought to be computers during those times. You see how big it is. So that is the ENIAC computer. And it was, this was actually in the University of Pennsylvania, somewhere in 1945. And you can see the size of this particular computer. It was over 100 feet long, and it was filling about 30 feet by 500 feet room. So you can imagine how long it was. In terms of height, it was about 10 feet, and depth 3 feet, weight was about 13 tons. So that is the ENIAC. At that time, it cost around almost $500,000 US. Even currently, this amount is still quite huge now. So these were the things that made up the first type of generation of a computer. Now, the second generation also spans between 1950 to 1960, and it is marked by a significant transition from the first generation, which was characterized by vacuum tubes, to a new era of computers using transistors. So this technology, so from here, you can see there is a huge technological shift that's made it possible to improve the size and the reliability and performance of the type of computers that evolved within that particular decade, which is the 1950s to 1960. And these were the characteristics of those computers at that time. They were characterized by transistors. They were using transistors which replace the vacuum tubes. Of course, when the vacuum tubes, as you saw, as explained with the old black and white TVs that I talked about. So that they used transistors this time around, and by the use of transistors, they were able to replace the vacuum tubes. Vacuum tubes were quite big. So using transistors reduced the size and the heat that emanated from the vacuum tubes. And they also found a way to introduce assembly language programming instead of using the machine learning programming from the other one, which is this one, but rather use assembly learning. And also they had the magnetic core memory improved. The magnetic core memory, it also was a good thing in this particular era. And what it did was to improve the storage of the data that they will use in doing their computations. It was good in a sense that batch processing also continued from here. And now, but some of these systems supported multi-programming. Notable amongst such computers at that time are these ones: the IBM 700 series, the UNIVAC, the UNIVAC 1107, and the CDC 1604. Those, I would want to see pictures of those ones. These are how some of that generation looks like. When you go online to Google, there are lots of them that you can see in there. So going on to the third generation. So this actually also spans between the 1960s and also 1970s. So witness further advancements in the hardware software. So you could see from vacuum tubes, we came to transistors, and now this time round, we are into integrated circuits. So those were the characteristics that helped replace the transistors at that time. And of course, in this case, it was no more assembly language programming, but rather they brought in high-level programming like COBOL and Fortran that were introduced in the computation of the, in the operating system that were used. This time round, they had operating system that gained prominence within this particular year, the 1960s and the 1970s. So time sharing system allowed multiple users to also interact simultaneously. So notable amongst them were these type of computers. And this is how it looked like. So those are the third generation computers, the integrated, and of course, that was when they started the use of the integrated circuits instead of transistors. And this is the third generation computers. The fourth generation computers also started somewhere in the 1970s and continues through to the 1980s. And they brought about significant advancements in microprocessors, which microprocessors technology, personal computing, and also the integration of various components on a single chip. So by the introduction of microprocessor and microprocessor computer, it helped in coming out with the fourth generation computers. So these are the characteristics of it. There was a very large scale integration technology, which helped increase the chip complexity. We had personal computers becoming popular within that time in the 1980s. And we have the graphical user interface and the networking, which was also developed to, for computers to also talk together. Now, for the graphical user interface, like what you see in here, graphics, so pictures. Before all those times, if you want to talk to a computer, you have to type, in a command prompt. So you have to know how to type. But from the fourth generation, they integrated the graphical user interface. So if you click on an icon, there is a set of instructions behind the icon that is executed. So in previous times, you might have to type to be able to execute commands on a computer. But this time around, they built icons and they built graphical user interfaces that had, those commands behind them. So users didn't really have to memorize those commands, but rather just use the graphical user interface just to perform other tasks. So notable amongst them was the Intel processor. So these were the Intel 4004 processor, IBM PC, Apple II. You can see an example of the fourth generation computer. This is what's it looks a little more portable, but not in our current, not currently. But that time, if these set of PCs or computers were quite good in the 1970s and 1980s. Now the 5th generation, that is from the 1980s to our current state, which is the present state. So that is where the 5th generation falls within. The 5th generation of computing technology refers to the era that begins in the 1980s and extends to the current day. So this generation is characterized by the advancement of parallel processing, artificial intelligence, and increase in integration of computing technology into various aspects of the daily life. So that is the 5th generation of computers. As you know, artificial intelligence has come to stay. And all is because with artificial intelligence, we need data. And humans are believed to be producing about 2.5 quintillions of data, every day. So you can imagine what that data could be used for. Now, these are the characteristics of the 5th generation computer: advance in the VLSI technology and a parallel processing, artificial intelligence and expert system, reduced instruction sets, computing and architecture, and also networking and the rise of the internet. Of course, internet started moving up somewhere in the 1950s. So notable amongst the 5th generation is the supercomputers, Intel Pentiums. Now, even now, the Pentiums have even gone down. We're having different processors that are helping us, perform certain tasks. So these are some of the computers that exist in our current state, which is the 5th generation. Artificial intelligence, 5th generation computer, AI. All these are examples of, an AI trying to play a game with a human. So that is about it. We believe that some time to come, certain things will be happening behind the scene. We probably will move from having to use the computer to perform tasks for us to possibly imagining things happening and them happening there and then for us to see. Those could be possible. We believe that could be possible. Let's see how it goes some years from now. All right, so now we've talked about the computer the computing system. Of course, we need to also talk about the computer hardware, because the software and the hardware together, come together to form the computer system. So for the computer hardware, anytime you hear of a computer hardware, anything that you can touch on a computer is a computer hardware. If it's a component of a computer, then it's a computer hardware. So those are the tangible or the physical components that make up a computer system. So the tangible or the physical components that make up a computer system is a computer hardware. So these components work together to process data, execute instructions, and also perform and also provide some sort of platform for the running of software application. Without the hardware, the computer hardware, no software application will be able to install on the hardware and make it possible for us to use it. The software, we can think of the software as maybe the spirit that lives in us, and the hardware as the body itself. So if the spirit in us leaves our body, then it means we don't exist, we are dead. So in the same way, for the computer to be called a computer, we need the hardware, which is the body, and the software, which is the spirit, for both of them to be talking to each other, for them to perform certain activity. Now, when we talk of the computer hardware, these are some of the things that we normally would want to associate ourselves with. The central processing unit, the storage device, the input and output devices. The CPUs, which we have already talked about, refer to the brain of the computer, The CPU is responsible for executing instructions and performing calculations, which I've said earlier on the earlier slides. We have the storage devices. So those are the hard disk drives. That is the HDD, which is hard disk drive, and the solid state drive, which is SSD. They provide a long-term storage for operating system and also software application and also user data. So the hard disks always contain the operating system and other software application that we deem necessary to put on our computer. Of course, the hard disk also makes it possible for us to save our user data on the computer. Usually, generally, when you hear of the HDD, which is the hard disk drives, they use magnetic storage in storing data. However, for the SSDs, which is the solid state drives, they use flash memory for faster access speed. So if you have a laptop and it's using this type of hard disk, which is HDD, then it means it will not be as fast as having SSD, which is solid state drive, because this one uses a magnetic means of storage, of storing data. And it does that by spinning. There is actually something like a disk that spins inside the HDD. But these SSDs, nothing spins. It's just chips that makes up the disk, which is a solid state disk. Input devices are devices that allow users to input data with the computer, which some of which includes these that have been outlined in here: keyboard, mouse, scanner, and camera. And we have the output devices. So those are devices that present processed information to users, such as the monitor, the printer, and also the speaker. Now, there is this device that we normally term as input and output device. And that device is called the modem. The modem, so an example, for instance, an exam or a quiz, if you are asked to give an example of an input device and you say a modem, you are correct. If you are asked of again to give an example of an output device and you say a modem too, you are also correct. So for a question, I think the next time we meet, or yes, I would want to know, it's still going to be today. I would want to know the difference, what makes a modem an input device and also an output device. Let me pause this minute. Okay, sorry, I had a call I had to pick. Sorry about that. So yes, a modem is an example of an input and also an output device. I would want you to tell me, we will break for a short while, maybe about 30 minutes and continue again. But before that, so that is the question I will ask one person to to tell me the difference between what makes a modem an input device and also an output device. Right, so moving on, so the components of a computer system, we have the CPU, which is what has been outlined here. The CPU is made up of the control units and also the arithmetic logic units, which you can see over here. So the control units makes up the CPU, and finally we also have the RAM and also the ROM. They all reside more or less in a way in the CPU, but this is what makes it. This is the CPU itself. This is the CPU. Control units, arithmetic logic units. The RAM is also situated elsewhere. There's a random access memory and the read-only memory. All right, so those are the memories that goes in there. So these are the inputs units and also the output units they are all part of what makes up the components of a computer system. All right, so this is generally what it is. So inputs units. So we have data being passed on through the inputs units to the CPU either the control units or either the arithmetic metric logical units. If it does goes to the control units and there is some sort of arithmetics that needs to be done, it is passed to this arithmetic logical units. The control units then eventually coordinates the right place to output the information that we need to the output units. And this could be in the form of information or knowledge. And if we do output, it possibly will be on the screen or on the printer as a computer monitor, or it will come out as a printer. So these are the auxiliary memories. They form, we have the memories with the random access memory and the read-only memory coming in over there. The computer hardware organization, when you hear of that, it refers to the arrangement and also the interconnection of the various components within a computer system. So we are talking about computer hardware. So of course, the component that we mean here is the hardware component. So the arrangement and the interconnection of the various hardware components within a computer system falls under the computer hardware organization. So the organization of a computer hardware is designed to ensure efficient communication and also coordinating between different types of the system. By so doing, it enables the execution of instruction and the processing of data. Now, the key aspect of the computer hardware organization are what has been outlined in here: the CPU, the motherboards, the inputs, outputs, the power supply, the cooling system, the peripheral devices, and the networking hardware. So when you, in a quiz or an exam, when you hear of the key aspect of a computer hardware organization, these are the things that you should be looking out for, and they all fall in here. So this is the motherboard. This is the motherboard. This is the hard disk that I talked about, HDD, hard disk drive. So this device is able to read data on this device. Of course, the hard disk is not open like this. It's actually closed, but this is just a representation of what it is. This is how the memory looks like. This is the CPU. It goes in here. And this is the display and the keyboard. Now, to know where the CPU is, CPU, as we said, is the brain of the computer. It means it's always working. If it's always working, then it means it becomes hot. So if you open a computer and you want to know where the CPU is, you need to look out for a place where the fan is. So where the fan is, either by it or beneath it, you will see a heat sink, and under it, you see the CPU. The CPU is always thinking, so it becomes hot. When it becomes hot, it needs to send that heat away from it. So in sending that, the fan blows over it to cool it off. So anytime you open a computer, be it a desktop or a personal laptop, and you want to see where the CPU is, look out for where the fan is. It will guide you to know where the CPU is. So these are USB, Universal Serial Bus. These are PS2 ports for the mouse and the keyboard. These are the main part. This is the main power units. This is the video card, the network card, the modem. These are the sound or MIDI game ports that exist in there. So the motherboard's continuing. The motherboard is what has been outlined in here. This is the motherboard. It has so many components coming together to form it, the motherboard. So when you hear of the motherboard, it's also known as the main board or system board. It is very crucial when it comes to a computer system. It's one of the crucial components that exists. It is large, flat circuit board that serves as the central hub for connecting various hardware components, allowing them to communicate and also work together. So the motherboard is essentially the backbone of the computer. And it does this by, providing a platform for the integration of the essential components, all the components that we have over here that needs to go onto the board and helps the PC to function. is because of the motherboard. It's one of the essential components that, helps the integration of all these essential components. So these are the key features and functions of the motherboard. The processor sockets, which is the CPU sockets, the memory slots, the audio components. I think we have one person in here, Mabel appear. So you introduce yourself when we are done. All right, so we have the memory slots, we have the memory. So for the features of the motherboard, we have these that have been outlined in here. There are lots of them, as I spoke to you about from here. From here, there are lots of, these are the hardware organization for the motherboard. Things that goes, this is actually the computer organization, hardware organization. And for the motherboard, there are other things that goes in there. So the processor sockets. So what it does is the motherboard contains a socket or a slot where the CPU is installed. And this is the processor sockets, this one. This is the processor sockets. So you can see this is how the CPU, we have the CPU will be mounted over here. So this socket holds the CPU. So that is the processor socket. Yes, so the CPU is the brain of the computer, is responsible for executing instructions and also performing calculations. So that is about the CPU. And the sockets that holds the CPU is the processor socket or the CPU socket. We have the memory slots. Of course, those are also sockets or slots where we can mount our memory. So the memory slots, excuse me. So the memory slots is always on the motherboard. It allows the installation of RAM, which is the memory, random access memory model. The RAM is volatile, is a volatile memory. By volatile memory, it means it's unable to hold data for a very long time. It only holds it temporarily. So the moment you're working and the light goes off or you lose power to the computer, you will lose any data that is stored in the random access memory. So that's what makes it a volatile memory. So RAM is a volatile memory that provides a fast access to data to the CPU. So the motherboard determines the type and maximum amount of RAM that can be installed. So this is a word of caution to most of us, Of course, we can upgrade our computers. So if you have a laptop and you want to upgrade it, you first of all will have to know that the memory slot is able to hold the maximum RAM that you probably would want to install. So an example is there are some laptops that memory slot does not give access to put in just one RAM, which is about, let's say, 8 gig. So if you are using an old laptop and you go and buy an 8 gig RAM and you come and try to put it in, although it will fit in the memory slot, it might not work because the maximum amount of RAM that you can fit in that particular slot is possibly 4, but you are mounting about 8 gig one RAM. It will not work. So anytime you want to buy a RAM or you want to upgrade your laptop, you always will have to go online and check the maximum slots the maximum amount of RAM that you can install in the slot of your laptop. So just don't buy RAMs and try to install them. All right. If not, you just be wasting money. So that is about the memory slots. We also have the audio components. So on the motherboard, it typically includes the audio components such as the integrated sound card or audio codecs, along with the audio jacks for connecting speakers and also the microphones. Most of our laptops have all these things. And still on the motherboard, we have the chipset. So the chipset is a set of integrated circuits on the motherboard that manages communication between the CPU, the memory, the storage devices, and also all that peripherals. So anything that we do connects to our computer, those are the peripherals. So it usually consists of a NOT bridge and a SOUT bridge, each handling a specific function. Now, there is this key thing that you should have an idea of. I'm sure most of you have heard of BIOS, the BIOS firmware or the UEFI firmware. So the BIOS stands for, some of these acronyms are very key. I would want you to, try to remember them. When you hear of BIOS, the BIOS stands for Basic Input Output System. That is what a BIOS stands for. So a BIOS, or Unified Extensible Firmware interface, that is a UEFI firmware, is stored on the motherboard's memory. So it's what it does is it initializes the hardware components during the boot process and also provide a basic set of instructions for the operating system when a computer is being booted, when we boot a PC for the first time. By booting a computer, it's not by kicking it. I'm sure you know. It's just a way of when you put on the computer, it means you have boot the PC, or you've put on the PC. So the keyword or the terminology that we normally use is boot computer. Now, we have cold boot and warm boot. I don't know if any of you have an idea of what cold boot is. You can raise your hand and tell us what is cold boot and what is warm boot. What is the difference between these two? Cold boot and warm boot. I think this is a good opportunity to get to know Mabel. Mabel, can we see your face? And can you introduce yourself to us and why you chose this program?
Hello, sir.
Yes, but before that, this is me. I think you didn't come. Yes. So Mabel?
I didn't join early because they didn't post the link on the usual platform.
Okay,
It
that's
was
okay.
posted on a different platform, so
yeah, that's fine. So who are you anyway? Why did you choose this course? Virtually everybody gave an introduction of themselves. So
my name is Mabel. I'm Pia. So introduction, like introducing myself as in
just a short intro, who you are, that's all. I'm meeting you for the first time. Just a short introduction.
Okay, so I'm the training officer for Diamond Mine Goldfields, and I'm not, let's say, I'm not a science student. I'm not engineering student, and I find myself in the engineering department. So I need to be on the table of engineers. So and that's why I chose this course.
Okay, so your ultimate goal is to have a degree in mechanical? Is that it?
Hopefully, if possible.
All right, thank you very much. I think we can continue. Okay, it was on a different platform. All right, I'm sure that's okay. So yeah, there was a question that I asked the question, what is cold boot and what is warm boot? Anyone?
Cold booting is the process of turning on the computer from an off state. And warm booting is the process of rebooting the computer whilst it is on. Like,
In fact, you are right. So that is indeed the difference between a cold boot. Thank you, Kweku. So when you hear of cold boot, then it means the PC has been off and you are now putting it on. So that is cold boot. But you see, I'm using my computer right now to lecture. The moment I restart my PC, then it means I'm warm booting my PC. So that is the difference between a cold boot and a warm boot. Now, I talked about storage. So that is the BIOS. Let's talk about the storage connectors. So the motherboard features connectors for connecting storage devices such as the hard drives and the solid drives. So those are the storage connectors. So there are cables. You'll see some holes in the motherboard where you can connect the cable to connect to these HDD and also the SSD. So those are the storage connectors. We have the CMOS battery. CMOS battery stands for complementary metal oxide semiconductor. So that is what CMOS stands for. So CMOS increases, some of these acronyms do come out sometimes. So please get to know what they stand for. Now, when you hear of the CMOS battery, it's actually a small coin cell battery that powers the memory. Usually, the BIOS rely on the CMOS battery. There's one thing, that those batteries are the ones that we normally put in that flat. I don't know if any of you have seen. I think we have an example of a CMOS battery here. On the next slide, this is how the CMOS battery looks like. This is an example. It's a very flat. This is it. This is how the CMOS battery looks like. So your laptop or your computer, they all have CMOS battery in. Even your phone also have some small battery. That is how come when you put your some phones, I think some old phones will not have that. So for instance, your computer, when it runs dead, you see, and you have not charged it, you can't use the computer itself, but there is a CMOS battery behind the scene that is controlling the time and also the date. So anytime you charge your computer and you try using it, you see the time is not gone. The desktop computers that you have in your offices, the moment the CMOS battery dies, you realize that your date and time will be wrong. You will set it correctly. You put your PC off. When you come back and put it on again, the date and time goes back to some dates that is wrong. So that tells you the CMOS battery is dead. It's unable to, store some of these information that is being stored in the BIOS. So this memory contains the basic system settings, including the date and time, even when the computer is powered off. So even if your desktop, you remove the power button, and you let it lie down. That CMOS battery keeps running. It powers those basic components for you to use the PC. So that is how come the date and time, even if when the power is yanked off and you put it back again, you still have your date and time coming on correctly. So anytime you have the date and time, feature, always setting to the wrong date and time all the time, then it means your CMOS battery is dead. You just need to replace it, and that is all. We have the heat sink and the cooling systems, cooling solutions. So the heat sink, in some cases, the fan are attached to the motherboard to dissipate heat generated by the CPU and other components, which prevents overheating. As I said earlier on, the CPU is always thinking. If it is always, that's like humans. If you're always thinking, it gets to a point your brain is fried. You are preparing for an exams and you are studying 24/7 without sleeping. Your brain will become fried. It gets to a point you're unable to think. So that is how the CPU also behaves. So it also gets to a point it's unable to think. So you need to find a way to, once it's thinking, it becomes hot. So you need to blow cold air or this blow air over it to move the heat to a different place. So as I said, anytime you're looking for the location of the CPU, look for where the fan is. So this is where the CPU socket is. You put the CPU socket here. On top of it will be the heat sink. The heat sink will now CPU gets hot. It sends the heat to the heat sink. The heat sink absorbs the heat. On top of the heat sink, you see the fan. So the fan is always blowing air from the heat sink. And this heat is, of course, coming from the CPU. So that is a simple way to know where the CPU is. is located in your computer. This is a typical example of the motherboard. And these are the chipsets and other devices. This is a CMOS battery, as I said. There's a power supply connector. All these are things that, the CPU, the motherboard contains to help us help the hardware of our computer to coordinate with the software. All right. So I talked about the CMOS battery, which is the complementary metal oxide semiconductor. And I said it's a chip on the motherboard that contains the BIOS configuration and is responsible for the date and time and other information that the computer needs during startup. So normally the information, this kind of information will be lost when the computer is shut down or loses power for some reason, dead batteries, failure, power failure, and so on. So this is very key. All right, so this I have explained what it is and what it does. It's just this small thing. Those that sells watch batteries, when you get to them, they can get you one. Or even sometimes even the remotes in your car keys remotes. The remotes can be usually also looks like this one. So that is how the CMOS battery looks like. There is a difference between data and information. I'm sure most of us already know. When you hear of data, you know what data is. All computer processing requires data, which is a collection of raw facts, figures, and symbols, such as numbers, words, images, videos, and sound given to the computer during the input phase. So data is what is unprocessed information, and it's always in the form of raw facts, figures, symbols, as has been outlined in here. So the computer manipulates the data to create information. You input data into the computer, manipulation or processing is done to something we call an information, which we would use. So information is data that is organized, meaningful, and also useful. So during the output phase, the information has been created into, it's put into some form, which could be in the form of a printout or a report or maybe a saved document and so on and so forth. So generally, the information can also be put in computer storage for future use. There are times when you are done processing your Word documents, you don't need to save that particular information, but rather you just put it on the computer. You don't need to print it out, but you save it on the computer for future use. So that is where, that is what we normally use information for. That information that has been processed from data for. So the transformation from data to information involves interpretation, analysis, and also contextualization, usually by turning raw facts into knowledge that can be used for further decision making and also understanding. Virtually everything that we do, for instance, if I want to, AI is now available. If I have maybe some sort of class with some sort of information that I need my Excel to help analyze, I can put in that data and I can get maybe a graphical representation of maybe a pie chart of the data that I've put in. So that is quite meaningful. So that is the difference between data and information. Data is a collection of raw facts. It's meaningless most times. But there are times to you, maybe what you classify as data might be information to me. It depends on the scenario. So data can be information at one point and can also be data at another point. It depends on who is going to use that data or information. So they would be able to classify what it's data for them or information for them. All right. So how does a computer know what to do? It's able to know this because it follows a set of instructions to perform specific tasks. And these instructions are provided through a program. So most of you have been hearing computer program. What is a computer program? Usually It is a sequence of coded instruction that the computer's central processing units can interpret and also execute. So the process involves several steps, and these are the steps that has been outlined. It goes on to the next slide. So for programming, when you hear of programming, a human programmer writes a program using a programming language. So this language consists of a syntax and also semantics that the computer can understand. The computer does not understand anything apart from zeros and ones. So the program that the computer programmer writes will conform to the syntax or the semantics that the computer would understand. So eventually, the computer will only understand based on the syntax and the semantics that the programmer uses to program whichever application that he's working on. When you hear of compilation and interpretation, the program is either compiled or interpreted. So for instance, a programmer would come out with a program by coding based on a syntax and a semantics. When he's done, he would have to either compile the program that he has created or he has to interpret that program. And that is done by the machine. So in the compilation or the interpretation, this is what goes in there. So the program can either be compiled or interpreted. When it is in compilation, the entire program is translated into machine code by the compiler. So the software that does the compilation is what we call the compiler. So in compilation, the entire program, if it is from here to here, that entire lines of code will be translated into a machine code by the compiler before execution. In interpretation, the program is translated line by line. So if this is one code, another code, another code, another code through to this side, what the compiler does is it compiles, it takes the entire program and the compiler now does the execution. It takes all the entire and does the execution. But when we talk of interpretation, what it does is it picks every line of code and interprets it line by line during the runtime. So it picks this one, it interprets it. It picks this one, it interprets it. It goes on by each line. That is the difference between compilation and also interpretation. All right, machine code. When you hear of machine code, the compiled or an interpreted program is in the form of a machine code, which is a set of binary instructions that a CPU can execute. I said computer only understands zeros and ones. So zeros and ones means we are talking about base 2. So in our core math, when you are told to convert 100 base 10 to base 2, you see, you end up with zeros and ones. So that is what the computer understands. Don't worry, I'm not going to tell you to convert hundreds to base 2. I'm sure some of you might have forgotten your commas. All right. So when you hear of loading, my computer is loading. So the machine code is loaded into the computer memory, which is the RAM, for execution. And when you hear of execution, what we mean to say is the CPU fetches instructions from the memory, decodes that instruction, and also executes the corresponding operation. So this process is known as fetch, decode, execute cycle. All right, so we have the registers and also the memory. The CPU uses registers. The registers are small, fast storage locations to temporarily store data and perform calculation. It also interacts with the computer memory to read and write data. So that's about the registers and also memory. Input, output, these ones you know. So the program may involve interacting with the input devices like a mouse, a keyboard to receive data, and output devices like these to display or store data. So it depends on the type of program you're running. So if it's a web application and it's requesting for your username, it means we need to use a keyboard to type our username. So that is where the input-output devices come in. The program may involve interaction with the input device, like the keyboard, to receive data. So when I enter my username, it means I'm feeding into the computer my username, which is being received by the computer. And when I do that and I log into the system, I might see some information about me, mentioning my name and who I am. We have the control flow too as well. Control flow, those are conditional systems statements, the if statement, if else statements, loops, and also branching instruction control. That flow, the flow of executing based on specific conditions. So the control flow, usually the flow of information from one point to the other. So if Kofi, then this. If maybe you have applied for diploma in plant and maintenance, then it means then you will take introduction to computing. So these are how control flows looks like. Moving on to the next, we also have the subroutine and also functions. So subroutines and functions. So they are programs often used for subroutines or functions, which are blocks of code designed to perform specific tasks. They can be called from different parts of the program. We have interrupts. So the CPU can receive interrupts, which are signals that temporarily halts the execution of a program to execute external events or requests. So right now, what I'm doing, I can now interrupt by, possibly coming in here and doing another thing. So the CPU can be interrupted in doing certain things. So that is how interrupt is. All right, so operating system interaction. So operating system manages resources, schedules, tasks, facilitates communication between software and also hardware components. So this is how the computer knows what to do at any point in time. It has to go through virtually all of these instructions to be able to perform some tasks. So now I'm moving on to the uses of the computer system. These are some of the uses of a computer system. We can use a computer for information processing. And by doing this, we normally process vast amounts of data, perform calculations, and also organizing information efficiently. So for information processing, in an exam or in a quiz, when we were told to tell us some of the uses of a computer, these are key points that you should be listing instead of saying playing of games or using Photoshop. You can use it for Photoshop, those general things. You have to talk about the categorized ones, like the information processing, word processing. There are lots of software which we can use for word processing. So for information processing, that is one key aspect of what we can use a computer for. So computers can be used for processing vast amounts of data, performing calculations, and organizing information efficiently. That is one thing. We also have the word processing. Word processing software enables the creation, editing, and formatting of text, document, facilitating tasks such as documents, writing, editing, and also printing. So an example of a word processing software is Microsoft Word. So as part of our practicals, we will delve into Microsoft Word. We'll talk about that one too as well. Internet browsing. What do we use a computer for? For internet browsing and so communication. So computers provide access to the internet. We normally use a computer to go onto the internet, do certain things, browse websites, send emails, receive emails, make calls, do certain things. There are lots of things that we can do with a computer when we have internet on them. So we can use it for internet browsing and also communication. We can also use it for multimedia creation and also editing. So most of the things that we have been dealing with in terms of flyer designs, graphics, video, audio, recordings, and all of that, it's all possible because of the computer. So computer supports the creation of and editing of multimedia content, which includes multimedia content. So it means multimedia, text, graphics, video, audio, animation, all those fall under multimedia content. So this is essential for graphic design, video editing, and also content creation. Programming and software development, yes. If a programmer wants to be able to develop a software, he needs to know he needs to have a computer. And we can use a computer for programming and software development. So computers are indispensable tool for software development, for coding and also programming tasks. They provide environment for writing, testing, and also debugging code. All right, so just like the application that you use to fill your online application to get into a program, that is a software that has been already created. So this was done on a computer. So you need a programmer to use a computer to program to create such software. And finally, on the last slide, uses of computer system, we can use it for data analysis and also research. So I'm reiterating again, when you are asked to tell of the uses of a computer, please mention these ones. Don't be telling me those generic stuff. Like you can use it to play game. You can use it to, no. Those ones are not acceptable. So data analysis and also research. We can use the computer to do research. We can use it for educational purposes, like what is happening right now. I'm behind my PC and I'm lecturing using the computer. Business and also finance. So businesses use computers for accounting, inventory management, payroll, data analysis, and other financial and administrative tasks. So for instance, inventory, Ransbet, for instance, they have an inventory system where stock, they're able to, you go to the lady at the counter, you are buying maybe 5 toothpaste. If there were 10 on the shelf, she does the software that is there, does a deduction, and we know that there are 5 left on the shelf. Possibly if it's left with 2, a signal is sent to the manager that Pepsodent is about finishing, so you should restock. So these are things that we can use the computer for. So business and also finance. Healthcare, computers are used in the healthcare for patients' record management. If you go to the new government hospital, virtually every hospital, there is at the OPD, that is where the patient's records are found. We use computers to be able to retrieve those records. Diagnosing, imaging, medical research and development of treatment plans, all these are possible because of a computer. And finally, graphic design and also animation. So designers and animators use computers and certain specialized software to create visual content, animation, and also digital artworks. So these are what we use PCs for. So this brings us to the end of our lecture 1. If there are no questions, sorry about this. So this brings us to the end of lecture 1. If there are questions, please let us know. We have Kevin Atu-Mensah. We missed you. Kevin. That's my little boy. Kelvin, can you introduce yourself to us? Kelvin, can you hear me? You are muted. You have to unmute yourself. All right, do we have questions? Is there any question? If there is none, I think we can break now. I would want you to let me know. Can I see? Okay, just a minute. Yeah, Calvin, please introduce yourself to us.
He is still muted.
Calvin, you are muted.
You have to unmute him.
Oh, okay. He should be able to unmute himself. Calvin, can you hear me? If you can hear me, we can't hear you. Whilst we wait for Kelvin, I've put up a poll. I would want you to answer the poll for me before we. So I'm putting up the poll right now. Yes, so please answer the poll. Let me know your concern about these two. I want to get some information from you. Yeah. Please, if you can hear me, check your phone or your computer. There is something, a poll on your screen. Check it and answer the questions for me. Check your phone, laptop, and help answer the question.
So please, we have, okay, well, I don't know, but I've answered. So I don't know for the other.
Yes, we left it 3 more people to answer.
Okay.
Do you mean a personal laptop?
We still need 3 more people to answer the poll so I can publish it for you to see. Then we'll move on.
Please, I can't see the poll. And also the first question,
Sir, all due
what I
respect, the question again.
All right, so let me just end the poll and publish it. So this is the outcome of the poll. So the question was, do you have a personal laptop? And out of 7, 4 of them said yes, and 3 said no. There is a practical session for this. So if you don't have a laptop, I'm wondering how I'll be able to teach you. And the second question is, should we end the lecture for today instead of breaking and coming back again somewhere at 4? Should we end the lecture for today and continue tomorrow from 7:30 to 12? And I think 4 of you said we shouldn't end it today. Those that says we shouldn't end it, can you give me any reason why we shouldn't? All right, we actually done with lecture 1. We're moving on to lecture 2. But before that, let's end here. Since majority says we shouldn't end it, I'll continue with lecture 2 with you at 4, exactly an hour from now. So when it is 4:30, we will have 1 hour more to start with lecture 2. So let's take about an hour break, 40 to 1 hour minute, 1 hour break. All right, thank you. So I'll meet you at 4:30 latest. If there is any concern, please let me know before we go.
Hello, sir. Hello, sir.
Yes, yes, Lord.
Yeah, we have a Telegram page where in our previous lectures we